Today we are going to talk about perception and neuroplasticity. I made a PowerPoint which I will include the slides right on above me so that we can walk together and explain the process. I'm going to be focused on hearing and its functions, but we're going to start off with explaining what is perception. So perception is a process through which information about stimuli is organized, interpreted, and transformed into something more meaningful. We use all of our senses, sight, hearing, touch, taste, and smell to gather information. When we gather all that information, we process that, and that is what makes the perception, how we translate that data that we have collected. Next is, what is neuroplasticity? So neuroplasticity is the brain's ability to heal, grow new connections, and reorganize in order to adapt to the environment. Think of the brain as a puzzle. And I included the picture of a brain and as a puzzle. So if I take a piece, what happens to the brain, and it's not connected anymore because I took the piece out. So then neuroplasticity makes the brain rewired to make a new piece to complete that puzzle. By rewiring the brain, you are making those new connections to replace the one that was missing so that it can still all connect, essentially adapting without the piece that was originally taken out. As I mentioned earlier, I'm going to be focused on hearing. All of this information that I have gathered explains it a little bit better, so let's just get right into it. Sound waves, they're the rhythmic vibrations of molecules that travel through air and other materials. Loudness, it is determined by the amplitude or height of a sound wave. And then sound stimuli is measured in decibels, which I thought this was very interesting because 0 decibels is the absolute threshold for human hearing, but normal conversations are around 60 decibels. And then noises at 140 decibels, they can be instantly detrimental to hearing. Pitch, it's the how high or low a sound is. Frequency is the number of sound waves passing at a given point per unit of time. And then the timbre is the sound texture. I included a picture of the ear, and I'm gonna go ahead and describe all of the parts of the ear and its functions. So we're gonna go ahead and start off with the pinna, which is this one right here. It's this outer ear, it's visible, and the main function of that is to collect sound waves from the environment and direct them into the ear canal, which is right here. And this is the ear canal. The ear canal is a 2.5 centimeter tube connecting the outer ear to the eardrum, which is the part that is pink highlighted right there. The main functions of that is to channel sound waves to the eardrum. The eardrum is that cone-shaped, it's pink. It's a cone-shaped membrane separating the outer ear canal from the middle ear. The main functions is to act as a barrier and a translator of sound, vibrating rapidly when hit by incoming sound waves. And then we have the ossicles, which is 3 microscopic bones, the malleus, incus, and stapes. They are the smallest bones in the human body. The main functions of those are to amplify sound vibrations from the eardrum and transmit them into fluid-filled inner ear. Then we have the I'm sorry if I'm not saying it right, the eustachian tube, which is this part right there. That is a narrow line canal that connects the middle ear cavity to the nasopharynx. The nasopharynx is the back of the nose and the upper throat. The main functions of that tube is to keep the air pressure inside the middle ear equal to the atmospheric pressure outside. Then we have the auditory nerve, which is that right there. And that is a bundle of nerve fibers that connects the inner ear directly to the brainstem. The main functions of that is to transmit auditory data from the ear to the brain so that it can be interpreted as sound. And then finally we have the cochlea, which is that snail purple looking thing like. And then the cochlea's functions are to convert mechanical sound vibrations from the middle ear bones into electrical neural impulses that the brain can understand. So what would happen if we lost hearing altogether? This is where neuroplasticity comes into play. So the brain has to make new connections so that you can adapt to the environment to process that information. By making new connections, or in this case, enhancing your other senses, we would rely on touch to make up for the sense that we lost, which will be hearing. When I was gonna say musical. When instruments are playing, we can't see the vibrations, and if we can't hear them because we lost our hearing, we can definitely feel them. When they're playing the drums, you can feel the vibrations. When they're playing guitar, if your hand is on the guitar, you can still feel those vibrations. So we are enhancing our other senses to adapt and make up for the one that we lost. So we rely on all of them as a bundle to, you know, the brain enhances those connections, makes them stronger, which makes up for the connection, the hearing that we have lost. I hope that my video explained it a little bit better, and if you got confused, I'm so sorry.